Hello friends. Today we are going to start with our next topic. So the topic is breakdown of solid dielectrics in practice. There are certain types of breakdown which do not come under either intrinsic breakdown or even in thermal breakdown, but actually occur after prolonged operation. That is, for example, breakdown due to tracking, breakdown due to electrochemical action, and the partial discharge. Now, what is mean by a prolonged operation? Prolonged operation means whenever a dielectric, that is any solid insulating material, experiences the supply voltage and experiences the current, that increases the temperature of the insulating material. This rising temperature increases the heat of the insulating material with the conducting material. So the heat of the conductor which carries that current and the heat of the insulating material which is provided on that conducting material both increases. Now this particular heat, if it is persist for a period of time, or if that particular device is in use for long operation, then there are the chances of formation of different breakdown. So the first example which we are considering is tracking. Now what exactly tracking is? For that purpose, let us consider a simple cable which is provided on the conductor. So there is a bunch of conductor which are placed inside the cable insulating material. So I just consider this as the cable, maybe of rubber or PVC, and inside it there is a conductor which is carrying current. Now that current carried by that conductor is for long period. Now due to this, the tracks get formed on the cable, and as soon as conductor carries the current, that tracks get conducting. As tracks are nothing but the cracks on the cable insulating material, that is due to the deterioration of the life or the material strength. So when heat increases, that affects electrically as well as mechanically. So the electrical parameter, that is resistance, and mechanical parameter, that is strength of the material, both get affected. So this increasing heat many a times affects on the resistance, as it is inversely proportional to the temperature for the insulator. So temperature rise increases the heat but reduces the resistance, that is electrical property of the insulator. As that electrical property get corrected, or like electrical property get affected, the mechanical strength of the material also get affected due to continuous heat up of the insulating material. So whatever the tracks, which are also called as cracks, formed on the insulator acts as a conducting material. So that basically provides the path to the leakage current, and that increases the gradual breakdown on the surface of the insulator. Now, when this heat is developed with the rising temperature, heats up the insulation. So it means the resistance get reduced. Resistance get reduced. So this heat on or heat of the insulator develops certain kind of gases and hence the electrolysis. So when that electrolysis of the insulation takes place, that is called as the chemical transformation. Chemical transformation. So this is basically takes place due to the rise in heat. Now, whenever we have a air pockets or gas pockets, like if I just consider a simple insulator that contains certain pockets available, those pockets of any shape, which is present in the insulator, then those pockets are dangerous because that reduces the insulating strength of the insulating material. These air pockets definitely acts as an insulator but is not continuous, and therefore that is present in the inside of the insulation. So therefore a partial discharge, a small discharge takes place due to those pockets, and this partial discharge may convert it into the electrochemical and the trackings, and hence that may convert that particular insulating material into the conducting material. Generally, we have the usage of impregnated paper in case of high voltage cables and capacitors. And if that particular impregnated paper contains the small air pockets, then the chances of occurrence of partial discharge on those impregnated paper becomes more. So this particular breakdown on the solid dielectrics takes place due to the prolonged operation. Now let us understand one by one the process of this breakdown. So let us start with the first, that is chemical and electrochemical deterioration and breakdown. Chemical and electrochemical deterioration and breakdown. What is chemical and electrochemical? First, I just consider electrochemical. Basically, electrochemical means the electrical energy due to which the chemical effects takes place on the insulator called as electrochemical. And chemically, when there are the chances of formation of the gases of the insulating material called as chemical reaction. So basically, that heat which is developed may burn the surface of the insulator, or maybe the PVC cable or the rubber insulation. And this burning definitely develops the gases called as electrochemical gases, and due to which the breakdown takes place. So this is generally takes place due to the presence of air and the other gases. Some dielectric materials undergo this chemical changes when subjected to the electrical stress. And that electrical stress is nothing but the supply voltage and the discharges or the charges which are accumulated on the insulating material. Some of the important chemical reactions that takes place are notified here. So first one is oxidation. This oxidation basically is due to the presence of air or oxygen, and it takes place generally on the materials such as rubber, polyethylene, that undergoes the oxidation, and that gives rise to the surface tracks. So you can see those are surface tracks in this particular example noted here. Those tracks are noted here. So this is the first chemical reaction that occurs. Another reaction that takes place due to the hydrolysis. Hydrolysis is nothing but the water or the moisture. That is, water contains on any of the insulating material or the moisture contains on the material. So you can see this particular insulating material, say paper. Here the example which we consider is cable, where we have seen the oxidation. And on this side, there is a example considered as paper. And on paper, you can see the accumulation of the water droplets. That may also called as the moisture. That may also called as the moisture. So when this moisture or water vapor is present on the surface of a solid dielectric, the hydrolysis occurs and the materials lose their electrical and chemical properties. The electrical property, it is in terms of definitely the resistance, and the mechanical property is nothing but the strength of the material. Strength of the material. So when this moisture is present, the moisture content starts acting as a conducting medium, because as we know, the water is a good conductor of electricity because it conducts. So whatever the insulating material has a higher value of resistance becomes the conducting material. So it affects on the electrical property of it. And slowly it will affect on the mechanical strength of the material. And when it reduces, that may give the puncture, which is also called as breakdown. So electrical properties of materials such as like paper, cotton tape, and other cellulose materials deteriorate when rapidly due to this hydrolysis. Plastics like polyethylene undergo changes and their service life considerably reduces. Same way, we have another point to consider, that is chemical action. So even in the absence of electric fields, the progressive chemical degradation of insulating materials can occur due to the various processes such as chemical instability. That is takes place at high temperature. So rising temperature burns the surface of the insulating material and therefore called as chemical instability. Oxidation and cracking in the presence of air and ozone, and hydrolysis due to the moisture and heat. Since different insulating materials come into the contact with each other, like there are the chances of having this chemical action between the different materials of insulation when it is used in, say, compact insulation, right? So when this insulations, two different insulations of materials, two different materials of insulations are used, then there is a chances of having a chemical reaction, and that chemical reaction is cause for the breakdown. So when these comes and with each other, the chemical reaction occur between these various materials and leading it to the reduction in electrical and mechanical strength. The important point which I want to mention here is the effects of electrochemical and chemical deterioration could be minimized by carefully studying and examining the materials. So this is our first reason or the cause due to which the breakdown takes place. Now let us understand the second reason, second cause of the breakdown, that is treeing and tracking phenomenon. So now let us discuss our next breakdown methodology. The reason or the cause to have the breakdown, that is treeing and tracking phenomenon. This particular treeing and tracking phenomenon takes place due to called as prolonged operation. Prolonged operation. But the reason for that is again electrical stress. We already had a discussion on this electrical stress. So basically what is mean by electrical stress, that I have already explained you. Stress is nothing but the application of voltage or the accumulation of the charges on the surface of the insulator. There are two visible markings which generally we find. Those two markings are the presence of conducting path across the surface of the insulation and a leakage current passes through the conducting path leading to the information of a spark. So the insulation deterioration occurs as a result of these sparks. Now, in this case, as we are saying treeing and tracking, so the definition for the tracking is the spreading of a spark channels during tracking. That is the spreading of the spark channels, that is called as tracking. And this spreading, it is in the form of branches of a tree, spreading of a spark channels in the form of a branches of a tree is called as treeing phenomenon. Tracking is the formation of a continuous conducting path. So this can be explained by simply considering an example of an insulator that may be say cable again. So we say whenever we have the cable which is used from a longer period, that forms the tracks on it. Those tracks are nothing but the cracks which are formed. And these are the dry cracks or dry tracks. So this spreading of a spark channels means that basically gives a path to the spark in the form of current. So current or this particular track becomes conducting, and that gives the channels or the path to the spark formation. And when these forms branches of a tree, like a tree branches, that is called as treeing phenomenon. So tracking is the formation of a continuous conducting path across the surface of the insulation. So we have seen this as surface of that insulation, surface of that insulation. On that surface of that insulation, due to the continuous use and rising temperature, the dry tracks get formed. Now that may convert it into the erosion also. So now to understand this concept, let us consider a simple example where there is a solid dielectric, there is a solid dielectric, that is solid insulation, having a conducting film and two electrodes. Let us say this is electrode 1 and electrode 2. Electrode 1 and electrode 2 are placed. In practice, the conducting film very often is formed due to moisture. So the reason for that is the formation of water vapor or the moisture. And when the supply voltage is given definitely to the conductor, the solid insulation get affected. So this film starts conducting. That film starts conducting. This is due to, or this resulting in the heat or generation. So that results in the heat generation and the surface becomes dry. Surface becomes dry. So the conducting film becomes separate due to drying. And so sparks are drawn, damaging the dielectric surface. So this formation of the dry tracks becomes conducting, and there are the chances of the formation of the sparks. With organic insulating materials such as like paper and bakelite, the dielectric carbonizes at the region of sparking, and the carbonized regions act as permanent conducting channels. So channels are formed. Like if we have a crack like this, then there is a chance of formation of treeing phenomena. So branches get formed. Branches get formed. So here if I have a track that forms the treeing. So for every reason, there is a formation of tree. There is a formation of tree called as treeing phenomenon. So this particular treeing and tracking phenomenon is experienced on the paper and bakelite and similar kinds of insulating materials. Now, this is a cumulative process, and the insulation failure occurs when the carbonized tracks breach the distance between the electrodes. So when these cracks are formed and continuous between the electrodes, so that it can breach the gap between the two electrodes. It can breach the gap between the two electrodes. So when it get breached, that becomes the reason for the formation of breakdown. So this is the cumulative process, as we said, and insulation failure occurs when the carbonized tracks breach the distance between the electrodes. This phenomenon called as tracking and is common between the layers of bakelite paper and similar kinds of dielectrics. On the other hand, treeing occurs due to the erosion of the material at the tips of the spark. And this erosion that results due to the roughing of the surface. So that surface must be smooth and polished to avoid the erosion and hence to avoid the tracking and treeing. Hence, that becomes source for the dirt accumulation and contamination. And that causes the increased conductivity. So this conductivity, as we know that resistivity is rho and conductivity is sigma. So that conductivity increases. And as the conductivity increases, that resistivity get decreased. And decrease in resistivity and increase in conductivity bridges that path and becomes the conducting path. Now, when a dielectric material lies between these two electrodes, which is shown in this figure, there are two different dielectric medium becomes. The first is air. So I just show you that air. So air which is present between the electrodes. The air which is present between the electrodes. So you can see that air which is present between the electrode and the solid insulating material. Let the gap defines that air presence as D1, and the voltage which is available for that, as V1. Now the voltage which is available on the solid insulator is V2, and the distance or the gap length of that solid insulating material is D2. So the air and the solid insulating material are now two different dielectric medium present between the two electrodes. So V1 is the voltage across air gap and V2 is the voltage across the dielectric. So the voltage V1 across air gap is given by the standard equation V1 is equal to V into D1 divided by D1 plus epsilon 0 by epsilon 1 into D2. Let us say this is our equation 1, where V be the supply voltage. Now, as we know that epsilon 2 is greater than epsilon 1, most of the voltage appears across D1. Now, if the voltage appears across D1, maximum the voltage across D1. So if I say V1 is equal to V, that is across air gap, the sparking will occur. That gives more sparking. That air get converted into the conducting medium. So the breakdown of this air material takes place first, and as that air ka strength, breakdown strength is less than the breakdown strength of solid insulating material, that air becomes conducting first. and hence the spark takes place. So the sparking will occur in the air gap and the charge accumulation. Now the charges will accumulate. This accumulation of the charges on the surface of the material takes place. On the insulating material takes place. Sometimes that spark erodes. Sometimes that spark erodes. As the time passes, the breakdown channels spread through the insulation in an irregular tree. So that there is no compulsion that tree will form in this pattern only. That tree may form in any of the pattern that follows the weaker path between the two insulating material. So you can see here the weakest path between the gap of the electrode is followed instead of having this. So whenever it follows that weakest path, the phenomenon is referred as treeing phenomenon. Under AC voltage, the condition treeing can occur in few minutes or may take several hours. Hence, care must be taken to see that there are no series air gaps or other weaker insulation gaps are to be formed. Under tracking occurs even at very low voltages that may be of say 100 volt. Whereas treeing requires some high voltage. So definitely tracks, that is nothing but the cracks formation, that is dry tracks due to the continuous heating of that insulation. But whenever we have the higher application of voltage continuously, the chances of formation of tree becomes higher, and that follows the weakest path between the gap of the electrodes. Treeing can be prevented by having clean, dry, and undamped surfaces and a clean environment. The materials chosen should be resistant to sparking or tracking. Sometimes moisture repellent greases are used. So this is all about this treeing and tracking phenomenon. Now we will learn about the next phenomenon, that is breakdown due to internal discharges. The next is internal discharge. This internal discharge is also called as a partial discharge. Internal discharge is also called as partial discharge. Internal discharge and partial discharge is basically takes place due to the voids or the cavities which are present in the solid dielectrics. This void or the cavity that may be within the medium. So that may be present within the medium. So let us consider this solid dielectrics, and that there may be the formation of a void inside the insulating medium. So this small void basically may consist of a gas or air, or that may be at the boundaries between a dielectric and the electrodes. So we have seen the last figure where the electrodes are placed on the above the solid insulating material. So there may be the chances of formation of cavity between these two electrode, that is electrode 1 and electrode 2. These voids are generally filled with a medium of lower dielectric strength. So this lower dielectric strength, it means that may be the air or gas pocket which is formed, but it has a very low dielectric strength. And the dielectric constant is generally represented as epsilon, that is epsilon for this particular medium, that is medium in the voids, is lower, and that is lower than the complete insulation. Hence the electric field strength in the voids is higher. In this void the electric field strength is higher. and electric field strength is higher, it means lower the gap. As you know, it is given by the equation E is equal to V upon D. So higher the electric field, lower be the distance, that is gap, but higher be the breakdown voltage, or whatever the voltage which is there, that is more than sufficient to develop the breakdown. So therefore, even under normal working voltage, as I said, that whatever the voltage which is available there, that is more than sufficient to get the breakdown. So under normal working voltage, the field in the void may exceed their breakdown value and breakdown may occur. Now let us consider a dielectric between two conductors, which we have already considered in last figure. If we divide that insulation into three parts, considering the capacitances, because capacitance is nothing but the insulation. And when two electrodes are separated by that insulation, that acts as a capacitance. So we are going to consider three capacitances. The capacitance C1 be the capacitance of the void or cavity. The capacitance C2 is the capacitance of the dielectric. The C1 and C2 both are in series, and C3 is the capacitance of the rest of the dielectric. The supply voltage to that as V, and then void voltage can be written as V1 is equal to V into D1 upon D1 plus epsilon 0 upon epsilon 1 into D2, where D1 be the thickness of the void, D1 be the thickness of the void, D2 be the dielectric thickness, that is thickness of the dielectric, and permittivities are epsilon 0 and epsilon 1. So this is our figure where we are considering a section of that complete insulation. So this is the complete solid insulation which we are considering here. This has a void which is shown here. So this is our void. Its capacitance, it is C1. The capacitance C2 be the capacitance of the dielectric, and both are in series. And capacitance C3 is the capacitance of the remaining dielectric. The gap between the two is D. Gap length is D. We can say that the thickness of this is, say, small d1. That thickness, that is void thickness, is given by the d1. Okay, and d2 be the dielectric thickness. In that case, it means it is equal to d minus d1. D minus d1. Okay, so now when the voltage is applied, V1 reaches the breakdown strength. V1 reaches the breakdown strength of the medium in the cavity. So that cavity voltage is called as discharge inception voltage. Discharge inception voltage, and the breakdown occurs. Now, when the voltage applied is AC, breakdown occurs on both the half cycle. In AC, we have positive half cycle and negative half cycle. So in both the cycles, there is a chance of occurrence of the breakdown. The voltage and the discharge current waveforms that can be drawn. So let us consider the details about the waveform. Here, the number of discharges depends on the supply voltage. So let us draw that waveform. We are making a waveform for AC supply with respect to time. So time is on x-axis and voltage just are on y-axis. So considering this x and y axis, the supply voltage waveform is sinusoidal, that is applied between the or across the electrodes. These are the positions where it reaches to 0. Then the void voltage is given by, that can be shown by the waveform, that is the void voltage V1. So supply voltage and void voltage. Now consider this point is the discharge inception voltage VI. This is VE. The current waveform can also be plotted for that. So the voltage and the discharge waveforms are shown in this figure. When the first breakdown occurs across the cavity, because that cavity contains lesser strength, so when the first breakdown occurs across the cavity, the voltage across it becomes 0. Now what the voltage across that cavity becomes 0. So V1 becomes 0. Now the breakdown cavity can be shown. Breakdown of cavity can be shown like this. So this is breakdown of cavity. Breakdown of cavity. That is breakdown which occurs in the cavity. That is shown. So the voltage across it becomes 0. When once the voltage becomes 0, the spark get extinguished. So basically the breakdown occurs, the spark forms, that is maintained by the void voltage called as arc voltage. That can be called as arc voltage. But as soon as this V1 becomes 0, the spark also get extinguished. The extinction completely depends on the amount of voltage, and that spark or an arc is basically maintained by the voltage called as arc voltage, or presently it is a void voltage. Now again the voltage rises, that voltage again increases till the breakdown occurs again. So there is a chance of occurrence of another breakdown. So therefore voltage, you can see it rises. So again it is V1, that is void voltage. And when that void voltage increases, again in second cycle we get the breakdown. So as I said, in AC, the chances of occurrence of breakdown in both the cycles is more. So the voltage rises till the breakdown occurs again. This process repeats again and again, and current pulses that can also be shown. So with respect to this, when the voltage is 0, the current is high. When the current is 0, the voltage is 0. The current is 0, the voltage is high, and so on. So that can be plotted for the current waveform for half of the cycle. So this is the current waveform which I have plotted only for the half cycle. So this process repeats again and again, and that will give the breakdown in both the cycles, that is half, positive half and negative half. So these internal discharges, which are also called as the partial discharge, will have the same effect as treeing on the insulation. Like the treeing phenomenon which we have studied in last discussion, the same last slide, the same is followed here also. So continuous process of the voltage increase, breakdown formation, spark extinction, voltage becoming zero, again that voltage is rising, is nothing but the treeing phenomenon. So this partial discharge is almost same as the treeing phenomenon. When the breakdown occurs in the voids, electrons and positive ions are formed and that has a sufficient energy, and when they reach the void surface they may break the chemical bonds. Also, in each discharge there will be some heat dissipation. Definitely when there is a partial discharge, the heat dissipation takes place in the cavities. So heat dissipates, it means there is a formation of certain gases, or there is maybe the carbonization of the surface of the voids. So as the surface of the void, so for that I just consider a void, and whenever there is a formation of heat, the surface of the void, the surface of this part that is void get carbonized and will cause the erosion of the material. These channels and pits that are formed on the cavity surfaces increases the conduction. So it basically reduces the strength of the cavity and hence overall strength of the solid insulating material, and that can result into the increase in conduction. So this particular surface acts as a conducting path. Now there is a chemical degradation may also occur as a result of the active discharge products that are formed during breakdown. So this gradual erosion of the material and consequent reduction in the thickness of insulation leading to breakdown. The life of the insulation with internal discharges depends upon the applied voltage and the number of discharges. So breakdown by this process may occur in few days or it may take few years. So this is basically the gradual effect which takes place if the void or the cavities are present in the solid insulating material. So therefore, there is need to keep the smooth and simple solid insulating material so that that can be used for the purpose of insulation. So here we have done with the topic called as breakdown of solid dielectrics in practice. So in solid dielectrics in practice, we have studied three effects. First is called chemical and electrochemical breakdown. Second, the breakdown due to treeing and tracking. And third is the breakdown due to internal discharge. So that's all with this topic. Thank you so much, guys.